Hello, in this video, I want to talk about machine learning using R, how to perform logistic regression analysis. And again, logistic regression is a statistic method developing statistics, but it also can be used as a machine learning algorithm for classification or prediction. Okay, so here's the brief review of logistic regression. Logistic regression is a supervised learning algorithm used primarily for binary classification tasks, predicting the probability of two possible classes. And it models the relationship between dependent variables and the probability of a categorical dependent variable using the logistic or sigmoid function, which outputs values between 0 and 1. Okay. And the algorithm estimates coefficient that explain the influence of predictor variables on the log odds of the outcome, typically using maximum likelihood estimation. So that's the parameter estimation method. And as we know in logistic regression, if you exponentiate beta, you get the odds ratio. So it's very convenient. Okay. Logistic regression is simple, interpretable, and effective for categorical outcome prediction, making it widely used in fields such as healthcare, marketing, and finance. Okay, so this is one of the most popular regression model for binary data. Okay, and also it assumes a linear relationship between the predictors and the log odds, requires no extreme outliers, and benefits from a large sample size for stable results. Logistic regression is computationally efficient and can handle various types of predictor variables, binary, ordinal, continuous, providing insights into variable importance. So there's quite a bit more information we can talk about logistic regression. For example, you can generate an ROC curve for a fitted logistic regression model if you use it as a classifier. Uh, and yeah, and I think you can also use it for as a predicting model or a classification tool. And you can do model selection because you have AIC value available for logistic regression. So you can search logistic regression on my YouTube channel to find many other videos on logistic regression. Okay. So in this video, we just want to do a very quick demonstration how we can do logistic regression in R. So let's get started. So set random seed, sample size equal to 200. First, we create a continuous predictor by doing a random sampling from a normal distribution. And then we create a categorical predictor, which is a factor as a categorical. Then we get control or treatment. So it's like um, binary. We have two values, control or treatment. Okay. And then we can specify the betas. So beta 0, beta 1, and beta 2. And then we can calculate the model linear predictor, which is the linear predictions combinations of all these predictors. So linear predictor is beta 0 plus beta 1 times, constant predictor plus beta 2 times, parentheses, categorical predictor equal to treatment. So these parentheses make it like a logical variable. If categorical predictor equal to treatment, it get a value 1. If it's equal to control, then you get a value 0. So it will compute the values accordingly and put it into the linear predictor terms. And after we have the linear predictors, then we can calculate the logistic function to get the probability. The probability is that using the logistic function. But once we have the probability of successes, we can create the binary dependent variable from probabilities by doing a random sampling from binomial, actually Bernoulli distribution with the probability. We calculate the probability of success. Okay. Then we just put everything together, and this is what the data look like. So if you want to perform a logistic regression analysis, your data should be looking like this. You get a dependent variable y, then you can have some one or more continuous predictors, and you can have one or more categorical variables. Okay. And it's fairly straightforward to fit a logistic regression model or perform logistic regression analysis. You use the function GLM, stands for generalized linear models. So you don't even need to install or load any R packages. GLM is available in base R. So the syntax of GLM, then you have this regression equation, y tilde, constant predictor plus categorical predictor, data equal to data, and you have to specify family equal to binomial. Okay. It's implied that the link equal to logit. The link function is a logit function. Okay. So if you run that, you will fit R will fit a logistic regression model for you. And if you use the summary to print out the model fit, you can see it has some call, give me the function, the formula for that model fit, and then to give you the coefficients. Okay, so you get the estimate, those the beta estimates, standard errors, z values, and the p values, and tells you which one is significant. Okay, and then you got some deviances and let's see here, tell you, okay, you get the AIC values, and you got you know number of Fisher scoring iteration. That's the algorithm, the iterative algorithm for the parameter estimation. You achieve the convergence by after like 4 iterations. Okay. And then we can extract a lot more from this fitted logistic regression model. For example, we can generate all the predicted probabilities for each and every observations in the data set. Okay, so I'll stop here. And again, if you want to learn more about logistic regression, just search the keyword logistic regression on my YouTube channel. You will be able to find more videos. All right, thanks for watching, and please like our video and subscribe to our learning channel, and also make recommendations of our videos to other learners who might be interested. Thank you very much, and I'll see you in the next video.